All right. So we left off over here doing these relationship problems. Now let me finish showing you these just so you have a handle for tonight's homework. Then there's a piece on the next page that's just review. We've done it a few times, but I'll show it to you because, sometimes people forget. Anyway, we had left off on question 19. And so on 19, what we saw here, speed and radius are constant, mass is increased, acceleration, AC. Well, here's your AC. The only equation we have for AC right now is v squared over r, which means that's what we're going to have to use. So AC becomes, notice that I'm not putting equals in there, but becomes, well, what happens to the v? It remains the same, so that's a multiple of 1. You must square it. You must still divide. What happens to the radius? It's constant, so that 2 gets that also gets a multiple of 1. 1 squared over 1, well, where does the mass go? It doesn't. It's not in the equation. Don't sweat it. So 1 squared over 1 is 1, which of course means remains the same, remains constant. Let's look down at question 21. Radius r, speed v are both doubled. What happens to the centripetal acceleration? Well, AC equals v squared over r. We know that. Now, let's see what happens to AC. AC becomes, well, v is doubled, as it says here, so it gets a multiple of 2. You're still squaring that, so let's square it. You're still dividing, so let's divide. R gets doubled, so that also a multiple of 2. Let's put a 2 down here. 2 squared over 2, that's 4 over 2, that's 2. What happens to the AC? It doubles. That's it. So the finesse method on this is quick, is nice. Now, question 22 is a little bit harder. I'll show it to you. It's less likely to show up on an assessment, but let's check this out. If the time, t, to complete one revolution is half the centripetal acceleration, well, we're assuming that the radius here remains the same because they made no mention of it. So basically, if not mentioned, comma, then the physical quantity, in this case, it is actually r, is constant, or is 1, it remains the same. So that's convenient, we don't have to worry about it too much. So the equation here, we're looking for AC. AC equals v squared over r. That's the only equation we have right now. Well, r is not mentioned, so we know that part's 1. We don't see the mention of v up here, so you might assume that's 1. That's why there's a little bit of a harder question. AC, remember you did in math, explicit and implicit dependence. Don't worry about the words, you have to remember them, but it's meaningful. You learn this in math, here it is. Up on question 7, AC explicitly, explicit means obviously, shown to you, written out, depends on V and R. Implicitly, does it depend on something else? Well, maybe. So you might think this is 1 over 1 down here. As it turns out, V actually depends on time. V actually depends on time. So again, this is a harder question. I wouldn't worry too much about it being a test question, but anyway, just in case, we would rewrite this equation as AC equals what V actually equals, which is now d over t. That's distance over time squared divided by r. That is an equivalent equation here, as long as that d is the distance or the circumference, and the time is the time for one revolution. So we can clean this up a little bit. AC equals, that's d squared over t squared over r, which should also be written, if you do a little keep change flip, or if you just recognize what's going on here, d squared over r times t squared. Just makes this a little cleaner. Anyway, now AC becomes, d is the distance around the circle. That's the circumference. That does not change. That's a 1. Squared over. R is the radius. That does not change. It's a 1. Times. The time up here is half. So you have to put a 1/2 or a 0.5. I've been using 0.5. Let me stick to the decimals because that's what we've been doing. Times 0.5, and this is squared. Now, if you put this in your calculator, what you will get is 1 over 0.25, which is 1 over 1/4, which is actually 4. So the answer here is actually quadruple. Quadruple, which is, by the way, not a crazy answer. If it takes you less time, that means you're going faster. And if you're going faster, that's a greater V. Your AC should go up. But anyway, don't lose sleep over question 22. If you got it, cool. If it was iffy, worry about the others. That's really your main business here. Now, on the back, actually, I'm going to make it a separate video.